Okay, so we move over to test for anions. Okay, now go to your manual, find out the anions you should know about. Okay, so these are the anions I have here on my screen. If that is what you have, fine. Okay, now anions like carbonate ions and sulfite ions, that's SO32 minus, we can um, identify them by simply adding only dilute acid to the solution. If you add dilute acid to any solution containing, let's say dilute hydrochloric acid, to any solution containing a carbonate ion, before you will notice effervescence. So if this is what they ask you for, you report effervescence, then you test the gas. We tell them effervescence of colorless gas. You check if it has odor, you report. Okay. Then you test the gas. If you test the gas and the gas is CO2, you found out how to test CO2 in your manual. You use lime water. Okay. So you test the gas. If the gas is CO2, then you write in your inference carbon dioxide, that's CO2 from CO32 minus ions. Okay. Then if you check the gas, maybe you have a colorless gas with a choking smell. Okay, that's likely sulfur dioxide. You check the gas and it's sulfur dioxide. You write colorless gas with a choking smell, SO2 gas from SO32 minus. Okay, then there are ions that cannot be displaced with an acid. These two ions we have, sulfite and the carbonate, can be displaced by an acid, but but ions like nitrate ions, halide ions, and sulfate ions cannot be displaced by dilute acid. If you add dilute acid in the solution, nothing will happen. Okay, if you add dilute acid in the solution and nothing happens, then you are suspecting these ions. Okay, to confirm these ions, we use what we call precipitation reaction. That is, we look for a solution that can precipitate these ions from their solutions. For halide ions, we use silver nitrate, okay, together with nitric acid. Okay. For sulfate ion, we use barium chloride together with hydrochloric acid, or we use barium nitrate together with HNO3. So if you are using barium nitrate, then the acid you are using is HNO3. If you are using barium chloride, the acid you are using is HCl. Okay. All right. If you take a look at our question 5, they said to the third portion of your solution, add barium chloride. So they are looking for sulfate ion. So you either confirm it, confirm the presence, or you confirm the absence. Okay. So if they said add the third portion of your solution, add barium chloride followed by addition of hydrochloric acid in drops. Okay, if the solution contains sulfate ion, which is this, what you will see is a white precipitate, which is insoluble in the acid. Okay, the white precipitate will form, and even though since it contains acid, the white precipitate will remain. But if this is not sulfate, maybe it is carbonate, the white precipitate will dissolve because of the acid. But if it is sulfate, the white precipitate, it will remain. So we are going to report white precipitate insoluble in the dilute acid. Then you report sulfate ion. Okay, if there is no white precipitate, you tell us sulfate ion absent. Okay, but if there is a white precipitate, even though including the presence of acid, we still have white precipitate, you say sulfate ion present. Okay, but if you have a white precipitate, anyway, it will not form as we have acid. But if you have a white, maybe they ask you to put barium chloride first. Okay, you put barium chloride first and you notice a white precipitate, don't panic, and you add dilute acid and what white precipitate dissolves, then it is not sulfate, it's likely to be carbonate or sulfite. because all these can form precipitate with barium chloride, but they will dissolve once it's an acid. They will form effervescence and dissolve. Okay, so if you have barium chloride, you are suspecting for sulfate ions, and if this is what you noticed, white precipitate is soluble in the acid, then sulfate ion present. Okay, if you are asked to add silver nitrate, then you are suspecting halide ions. Okay, silver nitrate in the presence of dilute acid, you will notice if it is chloride, you will notice white precipitate, not just white, heavy white precipitate. If it is chloride, to give you a heavy white precipitate and is insoluble in excess acid. So you just report white precipitate. You say chloride ion present. Then, if it is actually a chloride ion, if you add excess ammonium, aqueous ammonia, okay, it will dissolve in excess aqueous ammonia. Okay, if it dissolves in excess aqueous ammonia, then chloride is confirmed. Then if the precipitate is bromine, you will not have a clear white precipitate. You will have a creamy precipitate. A creamy precipitate. It will be white, but it will be like milk. A creamy precipitate. Okay, the same result with aqueous ammonia, but a creamy white precipitate or a creamy precipitate gives you bromide ion. Okay, if it dissolves in excess aqueous ammonia, it's still bromide. Then if your precipitate is yellow, if it is not white but yellow, you write yellow precipitate, you suspect iodide ion. The same result with aqueous ammonia. I hope this is taken. Let me stop here to avoid making this video long. Thank you.